over 2 factorial times x to the second. And that just basically becomes 1 plus pi x, right? Plus 3 pi over 2 x. Degree 2 Ernesto. Okay? We needed how many derivatives? 2, okay? Good? It's fun stuff, right? Kindergarten stuff?
Yes.
Alright, and one more. Oh man, I thought we were done. You're killing me, Smalls. You're killing me.
You're killing me, son.
You're killing me, Science. Alright, here goes. The last one, I promise, okay? We have 30 minutes. So, given that the second degree Taylor polynomial equals a plus bx plus cx squared is the second degree Taylor polynomial centered at 0, what can you say about the signs of a, b, and c if f has the graph pictured at the right? Justify your answer. So what can you tell me about a, b, and c?
Oh.
A is positive? How do you know A is positive? Where are we centered at?
0.
At 0. So that means f of 0 has to equal what? P of 0, right? And what would P of 0 be for this guy?
Greater than.
It would be A plus B times 0 plus C times 0, right? So basically what? A. And what is f of 0? According to this graph. This is 0. We don't know what it is, but we know for sure it's what?
Greater than.
Right? This is f of 0. So we could say, since f of 0 is greater than 0, and p sub 2 of 0 is equal to a, then what? A has to be greater than. Good? Alright. How about the b? What could we use to find the b? The derivative of f? So let's see, the first derivative of f at 0 should equal the first derivative of p at 0. And what's the first derivative of p at 0? Or, yeah, at 0. What would be the first derivative of this function? Maybe we should start off by writing that. What's the first derivative of it first? X plus just x
Oh, see?
plus 2cx? Should it be x here?
Is that B?
Should be b, right?
Yes.
b plus 2cx?
Yes.
Right? This is a constant, whose derivative goes away. The derivative of bx is just b, and the derivative of this is 2cx, yes? Okay. And if these two are equal, then that means that this guy at 0 is going to equal to what? B, right? So if I know what he's doing, and I know what he's doing, then I can know what B is supposed to be, right? So how can we determine the first derivative of f?
The tangent line?
The tangent line, right? So what would the tangent line be here? What would the first derivative be there?
Positive.
Positive, right? The first derivative would be positive. And we could say the first derivative is positive here because f is doing what there?
Increasing.
Increasing. You with me? So what could we say? Since f is what?
Increasing.
Increasing at x equals 0, f prime of x is
Positive.
greater than 0, right? Therefore, what?
B is greater than zero.
B is greater than 0. And we can make that connection because we're saying that the derivative has to be equal to this derivative.
Wait, do you have to show that work, or can you say it's positive just by looking at the graph?
Well, they want you to justify it,
Oh, okay.
B is
Okay. so you have to justify. You have to provide some reasoning. If it were multiple choice, you could just look at the graph and write what you wanted. Right? Okay. How about the next one? We're gonna have to use the second derivative idea, right? Because the second derivative of this polynomial is gonna give me what? What would be the derivative of this guy? 2c, right? You agree? Okay, so what do I know about the second derivative of f? Because it's equivalent to the second derivative of p. What do I know about the second derivative of this guy? It's negative. How do you know the second derivative is negative? Because it's concave what? Down, right? Okay. So we could say since f is what? Concave down at x equals 0. The second derivative at x has to be what? Negative, which is less than 0. So 2c, right, has to be less than 0. So therefore, definitely c is going to be what? Is that cool? You always have to justify based off of what you're provided with. So you have to tell me how you're making your conclusions about the derivative based off of the function that was given, which was f, right? Because f is increasing there, I know that the derivative is positive. Because f is concave down, I know the second derivative is negative. So on and so forth, okay? So you want to make your conclusions based off of what's provided. Good? Yes?
Yes.
All right. Good review. There's a lot of little A-B topics embedded inside of those questions. But the main idea, the main goal was a BC type topic. So you want to be able to understand. That's how they're able to test A-B topics and BC topics at the same time within the same test. All right. So good stuff, good stuff. So on your assignment, you have a couple of problems there to work on. You can work on them. Did I tell you to change this or no? Yes, that should be problem what? 6, okay? So make sure you change that to problem 6. And yeah, so there's a whole bunch of variations. There's a lot of them that are similar, like these guys. They're similar to the ones we just did, right? Okay? And you can go back and look at the notes to help you guide and get through them. Some of them require the calculator. So when they say calculator active, use the calculator, okay? Sounds good? Any questions? Not yet? Is the band well? For what? To practice.
Yeah, regional march.